Hello everyone, and welcome to the week 12 of the course Fundamentals of Micro and Nanofabrication. And I am Udip Dev, PMRF scholar from IIT Madras. And this will be the last problem solving session for this course. And so the last set of videos were on mostly on process integration, and we also saw some kind of demos, lab demos on how in real this fabrication works, what is the process flows, and some of the a lot of the things were kind of summing up the whole course, like how the unit processes, how they come together, and finally we get a device, and how to and also some crucial examples to see how small things can like affect your device performance, and how to troubleshoot also such interfaces. So that's what kind of summarizes this week's videos. So we will go to the directly to the questions, and this week was kind of simpler on side, and mostly the things were kind of theoretical and kind of visual that you see on the demo side here. So we'll go to that. So this is the problem one, and on kind of on cleaning. So it's kind of mix of how we recall what we studied in the kind of initial videos, and also just some touches of what we saw in this the ending videos too. So I have to tell what cleaning process we use for some newly procured wafers. So preferred method. So essentially, when we have a newly procured wafer, it will have all kinds of, if just like something that has just come from the vendor, it will have all kind of contaminations, yeah, metal contaminations, contaminations. Uh, the best thing is that we go for the RCA cleaning. So RCA cleaning has three steps, and that's how it takes care of all the contaminations, and because the other are kind of just some steps, this blow dry we do to like remove the solvents from the wafer. Piranha cleaning is something that is crucial for removing the metal contaminations. Solvent cleaning is something that the contaminations that are uh, soluble in one solvent, it is dipped in that and it is cleaned subsequently. So at RCA cleaning, it inside RCA cleaning they have the different three kind of cleaning, yeah? And that takes care of all the contaminations mostly, and it is recommended for newly prepared. So RCA cleaning will be the so we also learned about the clean rooms. We also learned about the clean rooms. So there we had some restrictions at how while entering the clean room. So we have to tell the PP is one of the important part of that. So it's just a small thing. Yeah, correct. This person productivity. Just try to just a quick question. We will go to the next one. So you have to select the correct statement here. C. Anything else that you think can be correct? Okay. So you think A is essentially wrong? Yeah?
Both are same da.
Audio putri cuma
We can use right. Use very dangerous. How can I? Everything will use. Okay, okay, okay. I take.
So you think A will be wrong? Okay, we will discuss that. So essentially, so the first, yeah, yeah, true. This one is yeah. So it is to remove the to remove the moisture, and you know why it is done? Uh, it is because these photoresists are hydrophobic in nature, so if the water is present it doesn't bind properly to the surface, so we tend to remove the moisture. So anyways, okay, so B, the thickness of a deposited film cannot be measured using step height measurement without patterning. So essentially, if we have the if the so essentially if the if the film has not been like it has been not been patterned, you will not get this step height, yeah, and you can't move the stylus to get the differences in step height. So this is a correction. Without patterning, we can't get this. Now the last one, that a cantilever release process can be achieved using an anisotropic etch process. So for a cantilever release process, so basically if we have a cantilever like this, so okay, so this portion is the mask. Okay. Now uh, this portion is what has been anisotropically etched. Okay, this portion. But the thing is to release, so considering this is the cantilever, to release it, we have to etch in this manner also. Okay. Yeah, getting it. So essentially, if it's like this, so this part, it is the top one, and this is the front side view. So you have to now also etch horizontally also. For that horizontally etching, we need something that can etch in the uh, isotropically, yeah? And it can etch like this, and eventually it will release it. So it will be a floating kind of, yeah. And that's why you will get like you may get things like this also, features like this also in the silicon substrate. So for that, so for the cantilever release process, we need isotropic edge process. So this will not be wrong. This will be wrong. So these are the options that will be correct. I hope you got it. Okay. Any doubts you can ask, and otherwise we'll go to the next one. Okay. So this is a question that they want to fabricate a device that is 0.5 microns width, width has 0.5 microns, and height is 2 microns. So what kind of edge process should be selected? So which one would be the best one to be used? Isotropic triads. Okay. Any other answers? C. Okay. So others are not. Others do not have any quick answers. Yeah? Okay. Then we will discuss the edge profiles first. Yeah. So essentially, if we are using wet, it means we are using wet chemicals, and dry is essentially dry agents, gases, vapors, compounds. But with like isotropy and anisotropy is basically isotropic is same in each direction, in same in every direction. While anisotropic will be selective. So it is direction selective, and this direction selective is mostly dependent on how it can remove silicon from a plane. So essentially, if you remember, when we have KOH, when we have KOH solutions, and we have a 100 plane here. So if we start etching it, it will have it has a it will have like this behavior, and this angle is 54.7. So this essentially is the 111, and this is the 1002. Yeah. So the as you can see, the aspect ratio and the angle is such that it is showing anisotropic etch profile. The best method which should be used for etching here would be the anisotropic dry etching, because otherwise, if isotropy is there, essentially isotropy won't be there, because it will have profiles of kind of like this edge profiles would be possible. And with anisotropic wet etching, this angle behavior of 54.7, the characteristic angle would be there. So essentially, as such, things are not visible here, and essentially it is a rectangular structure. The best method would be going for the anisotropic dry etching. Plus we have other controls also, so that can be used, and such things, such anisotropy and such profile can be achieved, like using the difference in all the gases, and also that can also affect. So here on a silicon substrate, so there are two substrates here. Here the first one has a silicon substrate, and second one is tin nitride, titanium nitride coated on the silicon substrate. So on both of this, germanium is coated and then melted to crystallize, okay, at 940 degrees Celsius. But in silicon substrate, we have such uniform profile, while in titanium nitride we can see droplets, germanium droplets. So what is the reason behind this?
ஆகஸ்ட் செப்டம்பர் ஆகஸ்ட் ஒரு மாசம் ஃபுல்லா வந்துருமா, செப்டம்பர் ஒரு மாசம் 9
Yeah, role of substrate is obviously this. So you have to tell that how is the substrate affecting here? What are the things that can have and how should we analyze the thing? That can also be interesting. Wetting. Okay. So how do you measure wetting?
சடனா விடலாம் வேகம் அவ்வளோதான் நீ
So let's see. If you have two surfaces here, and in this, so this is first case, and this is second case. So which one has higher contact angle? First and second.
So,
ஆனால் பக்கத்தில்
sir,
என் ஃப்ரெண்டே
thanks for
இருக்காங்க
you.
அதில்
சார் ஞாபகம் இருக்கா நான் ஐடியிலேருந்து பேசுகிறேன் இன்னொரு கரெக்ட் இன்னொரு ஒரு இதாக இருக்கணும் பார்த்து அது சேம் யூஸே தான் சேம் நியூ ஜெர்சி நீங்கள் அனுப்பிச்சிருக்கீங்க இந்த அட்ரஸ்க்கு ஸோ எவ்வளோ ஆகும் அது சொல்கிறீங்களா ஷூர் சார் அது கலெக்ட் பண்ண முடியுமா
higher
அதே லேப்டாப் ஓகே அது பார்த்துக்கலாம் நீங்கள் ரேட் சொல்லுங்கள் கண்டிப்பாக உங்ககிட்ட தான் செக் பண்ணுவோம் ஓகே ஓகே சார் ஓகே 500 கிராம்ஸு ஒரு நான் செக் பண்ணி சொல்கிறேன் ஆனால் டெஃபினட்டாக ஒரு 1 கிலோ இப்போ 500 கிலோ மேலேயான்னு எனக்கு
good. Yeah, good.
ஓகே
So basically this is the
ஓகே நான் இருங்க
angle that we measure. So it will have a,
சொல்கிறேன்
so
சரி ஓகே ஓகே
so essentially this is how that
ஆமாம்
contact
நீங்கள்
angle is
அதே
done.
அட்ரஸ் தான் நான் வேணால் உங்களுக்கு அதை பெர்ஃபார்மா இன்வாய்ஸ் அனுப்புகிறேன் நீங்கள் எதுக்கும் அதையும் செக் பண்ணி சொல்லிடுங்க
This is how
கரெக்டாக
the surface energy
ஓகே ஓகே சார் ஓகே தேங்க்ஸ்
is increasing. So if the surface energy is more, the drops tend to be like more like the drops have a lower contact angle and it spreads. Essentially it's you can think of it like whatever the bulk molecules are there, it because of the high surface energy they are also binding to the surface. Okay? So that's how it is increasing with the and that's how they are increasing the surface of the like the energy can be reduced here. So that's the thing. So here you can see in the first one, that is here, the surface energy is higher. So here the surface energy higher, so you will have the germanium tend to have will have a more spreaded structure, but here as the surface energy is very less, the drops are kind of, it's not spreading well, and that's how you will find such kind of globules, and it is not droplet kind of there. So that's the basic principle behind it. So yeah, a contact angle is a method that can help you learn the surface energy and also contact angle. Real contact angle helps, and you have some equations that I do not recall, but that can also correlate it with the surface energy of the surface. So this is a question that what do we mean by wafer throughput? So there's kind of a definition out of it. So these are four statements, and which would be the correct one. anybody would like to answer? I think nobody, only one answer came. So yeah. So wafer throughput. So throughput is something that is essentially very, like, people now talk about throughput through high throughput systems, and so it is kind of something that is related to the scale up, or how we can multiply the things. So basically, so D, option D is the wafer throughput. So basically it means how many where operations are done in a wafer per hour. So every facility, as these are very high end techniques, and maintaining the clean room and all the instruments are like, maintaining clean room itself is a big cost, and plus all the high end equipments are present there. So plus the wafer being like the wafer itself being a very costly thing, so costly element of our device. So number of wafers, so basically so number of wafers that are processed in hours. So it's something that quantifies, okay, so you can make such, so basically each wafer would have multiple devices here. So that's the rate at which such labs will perform. So these big Intel labs and all, they have very high throughput systems, and that's how they sustain their costs, because they have very high end clean room facilities and fabrication facilities. So option D would be the correct. If any other things, other options you have any doubts, you can ask. We'll move to the next one. So you have to tell in a fabrication lab which of the following is a fixed cost. other answers or any other options you think are correct?
தம்பி வாடா இந்த மாதிரி மூடுற மாதிரி வேணும்
Anything else?
ஹலோ
C. Okay.
ஆமாம் 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 இப்போ ஹாக்கி
So till now B, C and D has been.
அதே அமௌண்ட் எவ்வளோ 3240
Nobody thinks A is also
ஓகே 32
fixed first.
32ங்களா இப்போது நீங்கள் கலெக்ட் பண்ணுறது நீங்கள் நாளைக்கு மார்னிங் வந்தால் நீங்கள் கலெக்ட் பண்ணுவீங்க கரெக்டாக கேட்டுக்கு இப்போயா 8 மணி நான் உங்களுக்கு அது நான் உங்களுக்கு செக் பண்ணிட்டு சொல்கிறேன் ஒரு 5 மினிட்ஸ் வேணும் நோ ப்ராப்ளம் கேட் கிட்ட நான் கூட எடுத்துகிட்டு வந்து கொடுத்துருவேன் கிட்ட எப்போ வர முடியும் உங்களால் 7:30 ஆகிடுங்க நான் இது மட்டும் கன்ஃபார்ம் பண்ணிவிட்டு உங்ககிட்ட நான் சொல்கிறேன் ஒரு ஓகே ஓகே புரியுது ஓகே 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 சார் ஓகே நான் உங்களுக்கு கன்ஃபார்ம் பண்ணி ஒரு 5 மினிட்ஸில் ஃபோன் பண்ணி சொல்கிறேன் ஓகே இன்வாய்ஸ் ஓகேங்களா நான் கரெக்டாக நீங்கள் இன்வாய்ஸ் ஓகேயா போன வாட்டி நம்ம போட்டுருந்தா அதிகமாக அது மாதிரி நான் போட்டேன் அதே மாதிரி ஏன்னா நான் ப்ரொஃபார்மா இன்வாய்ஸ்ன்னு போட்டிருக்கேன் வேல்யூவும் நான் நிறைய கொடுக்கல
So
ஜஸ்ட் போன வாட்டி
by fixed cost, it means that it is something that is a capital cost kind of. It is something that
Last time
doesn't
actually
change
நம்ம
much
send
with
பண்ண
the
வேற
production
ஸோ
of the
அதுக்கு வந்து 8,000
of the lab.
இது
So
வந்து
it's something that is fixed.
வேல்யூ
So thing is here we think about the photo masks. So we discussed that how this photo mask can have
Okay, 5,000.
effects, yeah, because when we usually use it for this contact lithography
Okay,
processes, they
Okay.
tends to get contaminated because of the contact between the photoresist and the photo mask. So essentially we have to keep it changing, and also if you have designs varying, okay, so there you would need a different photo mask. So essentially with time it can degrade, and with design also it can change. So essentially it will be not fixed cost. Wafers is something that basically depends on your production, yeah. So if you have production if you produce less, you will use wafers less. So it's kind of not it's a dependent cost. Now chemicals also it's same, like the what if you have more processes to be done, chemicals processes needs to be chemicals expenditure of chemicals, or the way we use the chemicals will be more. Essentially it will also not a fixed cost. So essentially only the equipment is something. So if you have a exposure unit, so it is something that can sustain the needs of the lab. So it is something that is fixed, and it's most of the infrastructure things are something that is fixed. So essentially equipment will be a fixed component. Okay. Any doubts you can ask. So you have to tell which of the following are true. So it's true. These are true. Okay. Anybody else? C. Any other options you think are correct? Uh, so should we discuss? So we have to tell that how this protective equipment and it's a question about protective equipment. So if you remember that so there is actually two kinds of protective equipment. One is that is a common one, yeah, like common bunny suit, and so basically it is a common equipment. Plus, when we have any process, depending on how so any harsh chemical if we want to use, it will have so basically if we go for RC cleaning, RC cleaning, so you have to wear extra
Okay, so how much I have to send you?
3,000
3,200.
and basically hand protection also, arm protection actually, plus face mask, face shield, and plus also some local PPEs are also there. So basically, kind of gloves they are. So they are also used. So basically, it very much depends on the process that needs to be done. So this will be there. So and the second one, that it can be worn and stored only inside the clean room. So if you know that we can't bring out the gowns outside the gowning area, because there it can have it can collect contaminations. Yeah? So this will also be better. And the third one, that it should be washed and discarded. Essentially, if it is contaminated, you shouldn't use it thereafter, so that the next user can contact it, or also it enters again the playground area. So this all the things will be all the options will be correct. So any doubts you can ask. Okay, now we will move to the next one. So you have to arrange the steps of gowning for entering a fab facility. So these are the 6 elements that are lined up. You have to arrange everything on the floor. You can write it together. Not sure. Together in a single line, and that will be. Any other answers?
Finished the class?
I have sent you the latest address, right? Declared that address only?
Yeah.
Hmm?
Yeah,
In
yeah.
WhatsApp.
And I used this guy's phone number from our group.
Jose. Yeah, very good. Is that enterprise right there? So they will stick they'll put in their cover and put this address. Huh?
No, sir.
Do we have to write the address on paper or
No.
we have to take a printout and take it back?
No, we will take it.
Sure.
Sure. I've done this number of times.
So we'll discuss the solutions. So first, essentially, if you come directly from the outside, you first have to go through the air shaft, where to clear any. So first will be air shaft. So it will essentially dislodge any dust particles affect into your body. So first, then we should go for the face mask to cover our face. Then the thing would be hair mask. So to stop any hair follicles, to any dust from hair. Then we will go to the back side. So it's the suit complete. And then
சார் நீங்கள் ஒரு 7:30 போல் உங்களால் வர முடியுமா? நான் கேட்டில் வெயிட் பண்ணுறேன்.
and then the last.
ஓகே ஓகே.
And plus you have to take care of these things how the shoes are. So basically over the velocity. So you have to take such kind of thing. So this is the basic. So this is a question on how thickness measurement is done. So suppose you have deposited silicon nitride on a silicon wafer. So which of the following is a go-to tool that is used usually for measuring the thickness? So essentially we will discuss. So SEM is something that is used for morphology. Space is something chemical entities informations. And ellipsometry essentially thickness. And rectangular surface surface energy and wettability. Essentially in ellipsometry what they do is they place a wafer and from one side they launch so basically a polarized light. On this side is they have the analyzer. So essentially these light it tends to form a ellipsoid. So depending on how this is forming and they have these modeling softwares, they usually tell what is the thickness. So it's kind of indirect measurement. So that's how it works. And it can tell the depending on the models it can tell the thickness of the deposited layer. So essentially whatever you are telling is ellipsometry. So thank you for joining, and all the best for the exams. And that's all from my side, and all the best.